Good morning, Mr. Felix and friends. Today I'll be showing you L'Hopital's rule, how it works, and how to implement it into mathematics. L'Hopital's rule is a theorem that functions to evaluate limits which have an indeterminate value. These are the examples of indeterminate value. Indeterminate value are values that are unsatisfactory in calculus, as they have multiple answers. Let's take the example of 0 divided by 0. As you know, division is just the opposite of multiplication. So, what times 0 would equal to 0? You can put anything here. 0 times 1, 0 times 2, 0 times 3. Everything will be 0. So that means this has infinite answers. Same thing goes for this one, and that's the same thing that will go for the others. L'Hopital's rule tries to fix this by saying that the limit of an indeterminate fraction equals the derivation of the fraction. So the limit of fx divided by fy equals to f prime x divided by f prime y. This is the same for all derivations. To make it easier for you, I'll be showing you some examples shortly. Okay, for our first example, let's start off simple. We have the limit of x approaches infinity, 5 to the power of x divided by x squared. If we were to just substitute infinity in, it would become 5 to the power of infinity divided by infinity squared, which would become infinity divided by infinity, which is indeterminate. If we were to use L'Hopital's rule, on the other hand, first we derivate it. It would become x times 5 x minus, it's x 1 minus 1, which would become 0, and this would just become 1, and that would not exist anymore. And downwards we have 2 times x, 2 minus 1, which would become 1, and it would just still be x. So if I hit, it'll be something like this. 2 times x. If we were to substitute in right now, it would still be indeterminate. So we have to do L'Hopital's theorem once more, as these are just 1 minus 1 equals to 0, which x to the power of 0 equals 1, which would make 5 divided by 2. This is the answer for this. Okay, let's try a higher function now. Limit of x approaching 0, sin x to the power of 1 per ln x. If we were to substitute this, it would become sin 0 to the power of 1 per ln 0. ln 0 is indefinite. So before using L'Hopital's rule, we need to first times this by ln. So ln sin x to the power of 1 per ln x. We can just put this right here, which would become ln sin x divided by ln x. Now we can actually derive it. First we need to know how to derive ln, which is right here. So ln, the derivation of ln x equals the inside function prime divided by the original function. So this would become cos x divided by sin x. Same thing with ln x, it would become 1 per x. You can simplify this even further into x times sin x divided by cos x, divided by sin x. Now we can split these up into limit x approaches 0, x per sin x times limit approaches 0 cos x. We can now derivate this as the derivation of a indeterminate limit is the same as the original limit. So it would become x, it would become the derivation of this, which would become x per cos x times cos x. This will become 1 per 1 times 1, which would become 1. Now we have found out the ln y, so not exactly the limit, which is 1. All we need to define the limit is to just reverse this. So what? E to the power of 1 would become what? That would obviously become be e. E to the power of 1 would equal e. So the limit of x approaches 0, sin x to the power of 1 per ln x is e. That would be all in today's video. Thank you Sir Felix and friends for watching, and I hope this video explains L'Hopital's theorem in a concise and informative manner.